Today I'm going to talk about LeetCode question number 91, decode ways. Messages containing letters from A to Z can be encoded into numbers using the following mapping: A to 1, B to 2, etc. all the way to Z to 26. To decode an encoded message, all the digits must be grouped, then mapped back into letters using the reverse of the mapping above. There may be multiple ways. For example, we have this here. Note that the grouping 11106 is invalid because 06 cannot be mapped into F, since 6 is different from 06. So basically, the individual number cannot begin with 0. Given a string S containing only digits, return the number of ways to decode it. Okay. So like this, so let's just look at this example here. There are two ways to decode this, with 1, 2, or with just 12. So the answer is 2 here. And for here, there are 3 ways to decode it: 2, 2, 6, 22, 6, or 2, 26. So there's 3 ways. And for the last example here, obviously there's 0 ways to decode it because we cannot decode something that begins with 0. Okay, so how do we approach this? Well, this is kind of a dynamic programming solution. If we draw our decision tree here, for example, for 2 to 6, there are some paths we can take. For example, we could, in our number 2 to 6 here, we could take just a 2. And when we're trying to decode, we could just have an individual 2. Or we could have 22. So instead of like this, it'd be like this, okay? And then from 22, what we could do is have 6, and then that's it, that's the end of our path here. Now, what if we had from 2? What if we had 2 as part of our decoded message? So the next number we could take would also be another 2, or it could be 26. And at that point with 26, our path ends here. But what about this path? 2, 2, and then 6. And that's the end there. So therefore, there's 3 ways. Okay. So this is kind of a top-down approach. We could use recursion. This solution isn't ideal because we could have 2. The runtime would be 2 to the n, because for each decision we would have at most 2 choices here. We could use memoization to reduce it to O of n, but to have a true dynamic programming solution, I want to try a bottom-up approach. Okay, instead of a top-down here. So let's look at the bottom-up approach. So let's say we have 2 to 6. Okay, so with the bottom-up approach, what we want to do is, let's say we're at this index I here. If we're just at this index I, how many ways can we decode the message at index I? Obviously, there's only one way. We just have a 6 here, so there's one way. And I'll write that in red. So what about 2 here? How many ways? So what if our message was just 26 and 2? Or sorry, it was just 26. Okay, so with just 6, we can decode it in one way. If we had 26, how many ways could we decode it? Well, we could decode it. Obviously, we have to keep track of this ways here, so it'd be 1, 1 plus so it'd be 1 plus 1, which would be 2. Okay, so 2, 6, or just 26, that'd be 2 ways to decode it. And what if we had the whole string, 226? Well, what we want to do is the number of ways to decode it would be this answer here. So this one would be this one here. 2, okay, plus 1, which would be 3. Why 1? Well, we could do like to, so if this number of ways would be 6, this number of way would be 26, or 2 comma 6, this could be 2 2 6, or 22 6, or 2 26. Okay, and this 1 would come from this one actually. Okay, and where did this one come from? Well, it came from our base case here. That's our base case. Basically, at the end of the string, our base case would be return 1, and this is where this one came from. This one came from here, and this one came from this one. Okay, and obviously this 2 came from this 2. Okay, so I'll reiterate this. So basically, the dynamic programming equation would be, so dp at index I would be equal to dp I plus 1 okay, so if we had like 44 here, and then our base case is 1, so number of ways to decode 4 would be 1, and the number of ways to decode this 4 would also be 1, so our answer would be 1 here, because it would be 4 4. But what if we had 24? Or actually, what if we had 27? Obviously this would be one way, because the alphabet only goes up to 26, so this would also be one way, since okay, 2 comma 7. What if we had 26? This would be 2 ways, so our base case would be 1, number of ways to decode the 6 would be 1, and here number of ways to decode this would be 1, from this 6, plus this 1 here. So if applicable, we also want to do plus dp I plus 2. Okay, so 226. If we had this digit here, if we were just counting this one digit here, then obviously we want to get the number of decoded ways from this number. But if we were counting this as a 22 instead of a 2, we want to get number of ways from this number, the 6. So that's why it's dpi plus 1 plus dpi plus 2. Okay. And if applicable, we do this dpi plus 2. And when is it applicable? Well, if one of the numbers was a 1 here, or if this number was a 2 and the number next to it was less than or equal to 6, then it would be in the alphabet range. So this would be O of n runtime, and to take care of this dynamic programming DP array here, it'd be O of n space as well. Okay. So if we were taking into just this single 2 into account, we would just get the DP of I plus 1, and we also need to take these into account, so we need to, if this was I here, then we also need to take into account this. And if this were, I don't know, say 7 instead, then we just need to count for this, not I plus 2, because we can't have this as a possible solution in our decoded message. So now to code this up, what I want to do first, initialize my DP array, and it'll be of size length of s plus 1, y plus 1. Well, obviously we'll have the DP elements for, let's say we have 2 to 6 here, DP elements for each index in s, and plus 1 at the end will be our base case of 1. Okay. So now what I want to do is iterate it backwards. So for I in range s minus 1, and I want to iterate backwards because in order to solve this subproblem of if we had 2 to 6, this subproblem of how many ways to decode with starting at 2 for the rest of the string, I need to first solve this subproblem of 2 to 6, and then before I need to solve this 26, I need to solve this subproblem of 6. Okay. First, what I want to take care of is if at this index it's 0, then DP at that index is 0, because obviously at that index, if we had like 206 here, number of ways to decode at this index onwards would be 1. At this index onwards would be 0 because our encoded message cannot start with 0. And continue there. Okay. Or else what I want to do is DP at I is going to be equal to DP at I plus 1. Okay. Like if you had 44 at this index, number of ways to encode at this index onwards would just be 1. At this index onwards would also just be 1. And we're taking in this guy's count into account here, so it would just be 1 of 4. But what if we had 24? Obviously there would be 2 ways, 2, 4, and 24. Okay, so now what I want to do is, so I took in count just this index. What if it was just a 2 here? But what if we also took into account 24? So that's what I'm going to take care of here. So if I plus 1 is less than length s, but we're just checking we're in the range here. Like if we were at the end of the string, like if this was 22 and we were at the end of the string, then obviously we don't want to look forward. So if I plus 1 is less than s, and s at position I is equal to 1, or s at index I is equal to 2 and s at I plus 1 is in 0, 1, 2, 3, 4, 5, 6, okay, because greater than 27, that's out of range of the alphabet. And what I want to do is dp of I is going to be equal to self plus dp of I plus 2, okay? So with this guy, we're taking account the case where we have 2, 4, and with this condition, well, we're taking care of the case where if we choose to have 24 instead of just 2 in our decoded message. Okay, and then finally, after all that, I want to return dp 0 at 0. It would be all our accumulated number of decoded ways. So I'll take it for a dry run. Let me see. I think that works. Okay. Let me try other test cases here. Awesome, and I'll try submitting. Okay, great. Thanks for watching.